Now, take question, please. Right. There are three thermometers. There are three thermometers. There are three thermometers. One in contact with the skin. One in contact with the skin of the man. Of the man. Comma. Other in between. Other in between. Other in between. Vest and shirt. Vest, VST vest and shirt and shirt. And third in between shirt and coat. Shirt, shirt and coat. So what first one is what? So one in between, one in contact with the skin and man. One in contact with skin and man. Skin and man. So other in between vest and shirt. Vest and shirt. And third one is between shirt and coat. So these are three thermometers. So skin and man, vest and coat, and shirt and coat. Right. Now, full stop. The readings of the thermometers are 30 degree, 25 degree, and 22 degree. Are you understanding now? Degree centigrade. Respectively, full stop. The vest and shirt are the same thickness. The vest and shirt are same thickness. The ratio of their thermal conductivity is there. So if the vest and shirt of the same thickness, vest and shirt thickness are same, the ratio of their thermal conductivity is there. The ratio of their thermal conductivities, they are asking. Ratio of thermal conductivities. So now K west into area into delta temperature difference of west V into time of flow divided by length or thickness, that is equal to, and K shirt SH, I can put SH into area into delta shirt into time by L. So thickness are same. So that means we will be cancel these two belows. And the time cancel this. Okay. And the areas also same will cancel. Same thing, same area cross section. Now what is the difference? Now what you want to find? K west divided by K shirt. I am not doing anything, K shirt. So this is the temperature delta V by, not delta V, delta shirt divided by delta V. So that is equal to delta, what you call say, delta shirt. Delta shirt is, so shirt and coat, this one, 25 minus 22 divided by vest and the vest is there, where the vest is related with the, so vest is related with this one, okay, 30 minus 25. So now if you subtract it, how much you are going to get? This is a 3, see here all of you, this is a 3 by 5 answer. This is the ratio of this one. Understood? Temperature difference, shirt will come, shirt with the man. Okay, now shirt with, no, okay, what is that? Shirt to coat, no, this is a shirt. Now, the third, this minus this. Next, vest, where is the vest? Vest with the, where the vest is sleeveless. Man ki ikkada unnadi. That temperature. Right? Shirt, vest. Understood? That's all. Now go to the next problem. Take. All of you completed, understood? Go to next problem, please. Next problem, right? See here. Look for just a concept question. For cooking the food, for cooking the food, for cooking the food, the utensils must be suitable. The utensils must be suitable. Is, I'm giving answer directly. Is right. Low specific heat, low specific, low specific, low specific heat, low specific, low specific heat, and high conductivity, and high conductivity, high conductivity. Answer directly. What should be required? Low specific heat and high conductivity. This question asked a concept question. Now take next question. Right. A heat flux of, please all of you write, a heat flux of 4000 joule per second is passed through a copper rod, is passed through a copper rod of length 10 centimeter, of length 10 centimeter, and area of cross section 100 centimeter square, 100 centimeter square. Please stop. The thermal conductivity of copper is, the thermal conductivity of copper is 400 watt per meter degree centigrade. Please stop. Watt per meter degree centigrade. Please stop. The two ends of this rod, the two ends of this rod must be kept at a temperature difference of, must be kept at a temperature difference of, so you want to find a delta theta, must be kept at a temperature difference of, so everything is given. So if you use this delta theta, how to get this, these values are given, so you want to find delta theta. You know the formula, Q is equal to Ka into delta theta into T divided by L. Now we want this fellow. Now this is a Q by T, P is given. The value is 4000, I am writing shortcut method, 4000 joule per second is over. Now this is a given value is, but degree centigrade is there. Now this is how much? 400 watt per degree centigrade. Degree centigrade cancelled. Now areas are given. So area is given 100 centimeter square. That means convert into meter. 100 into 10 to the power of 1 centimeter square is equal to 10 to the power minus 4 meter square. Now length is given in centimeter. So I can write it as 10 into 10 to the power of minus 2. Okay. Now do the calculation. This is a, if you cancel this becomes 10 to the power of minus 1, 10 to the power of minus 1. If you take to the upper, 10 to the power of 1. So I can put here 0. So that is, now it will be completely cancelled. Now what is that? 10 to the power of minus 4 is there, 2 zeros, again 2 zeros. I will cancel this fellow. Now it is a 40 and 4. That I will cancel. How many? Okay. So this is 1 0 I will cancel, and 4 1 ja 4 100. Okay. What is the now temperature? Delta theta is equal to 100 degree centigrade. Answer. Calculation, you have to go shortcut like this. No need of steps. Right? Now, okay, next go to take another problem. All of you completed? All of you completed this one, take another problem. Right. A room is maintained at, take this question. A room is maintained at 20 degree centigrade, room temperature, 20 degree centigrade by a heater of resistance, 20 ohm connected to 200 volt main. Full stop. The temperature is uniform throughout the room. The temperature is uniform throughout the room, and heat is transmitted through a glass. Window of conductivity K. For glass. So conductivity of glass is GLS glass, window glass, 0.2 calorie per meter degree centigrade per second. So, and they are given J value, J is equal to 4.2 joule per calorie. Okay, sir. Here they are given length is given, length of the thickness of the window. L is equal to 0.2 centimeter, and area is already given 1 meter square. They are not given, they have to take it by printing mistake. So L is equal to 0.2, that is called thickness, and area is equal to 1 meter square. That's all. Okay, now we want to find what is the temperature. So what is the room temperature? What is the room temperature? See here. Now here, let them to see here. Now we want to find heat. What is the heat? So Joule's law, mechanical equivalent of heat. W is equal to JQ. W is equal to JQ. Okay. So W is equal to JQ. Now Q is equal to what it becomes? Q is equal to W by J. We call electrical work done I square RT. Otherwise I can say V square by R into T. So W is equal to I square RT formula. But I am going to find, I know voltage and resistance. In place of this, I can write it as I is equal to V square by R. I is equal to V by R. Then I square is equal to what becomes? V square by R square. R will be, okay, one R will be cancelled. Now this is the V square by R into T. Understanding? Now then you can substitute what you call it as a into J there, into 1 by J. I can put 1 by J. So this is equal to what is that? You are finding Q value. Q is equal to how much you are getting? V square by R into T time into 1 by J, that is equal to what is the Q? K A delta theta into T divided by L. Substitute all values, you will get your answer, please. Now this is this value, how much? This value is equal to 200 square by R value is 20. Okay, 200 square by R value is 20. So time this T cancelled. The J value is given, that is 4.2. So 4.2. The length is given 0.2. 0.2 centimeter is given. Convert into meter, 10 to the power of -2. and K value is given. K is equal to how much is given? K is 0.2, 0.2. Okay, and area, what the area is given? 1 meter square 1, and we want to find this one. Now if we simplify, then delta theta value you are going to get it as 15.24 degree centigrade. If we simplify, you'll get the value. Okay, right? Thank you. Hafiz.